The same as other question, the tips to solve this question is to translate the given information. They tell us about fx, and then after that they say that fx is divided by x minus 3, then the remainder will be 4. So this sentence, they say that when fx divided by x minus 3, then the remainder will equal to 4. And based on remainder theorem, we know that the remainder is f replaced by a suitable value of x, which is 3, so that the divisor becomes 0. So in short, that means they tell us f3 is equal to 4 from the first equation. And at the same time, they tell us another equation when fx divided by x minus 4, it is a factor. That means the remainder is 0. So f4 is equal to 0. They just try to use two sentences to give you these two equations, and then you're going to solve the equations. So something minus 3 squared times something plus h plus k is equal to 4. And you don't need to expand it. The advantage of substitution is you find there are some number and also number together, so you may combine them before you expand it. Make things easier. So this is 3 minus 3, 0 squared times 3 plus h plus k. Originally, I a little bit frustrated that it's h and k together, and then we still need to use simultaneous equation, something like that. But 0 times anything just simply 0. Some of you will easily think it's still 3 plus h. It's look like you're multiplying 1, but don't repeat the same mistake, please. So they try to tell you that k is just equal to 4. And then similar reason, right hand side we do the same thing. 4 minus 3 squared, 4 plus h, and then plus k is equal to 0. So this is 1 squared times 4 plus h plus k is equal to 0. So 4 plus h plus k is equal to 0. But we already know what is k. So I change k to our known value, which is 4. So h is equal to -8. We already get h and k. So h is equal to 8, while k -8, while k is equal to 4. In part B, how many rational roots does the equation fx equals 0 have? So part B, don't forget that we always start from question, solve fx equal to 0. And then we know fx pretty well, is our answer in part A. So this is x minus 3 squared, x plus h. We already know h is -8. And then plus k is 4, so equal 0. And then after that, we just need to ensure change it to how many x power 3 plus how many x squared plus something equals 0, and then we are going to factorize it. We always do the same when we are facing some cubic polynomial or with higher power. And then, so let's start. So x squared minus xx plus 9. Remove the bracket carefully. Write in 2 rows, ensure that you can find the like terms easily. So minus 4. And then read the question again. They tell us the factor, one of the factor already, which is x minus 4. They must give you some hints. So this one is x minus 4, and then something at the back. How do we know? Of course, by the long division. So 1 So another factor we find out is x squared minus 10x and then plus 17 equal to 0. So continue. They want to know how many rational roots, so we can't avoid to use the quadratic formula. Because your calculator do not give strong evidence enough to prove it is rational or irrational. So x minus 4 is equal to 0, or x squared minus 10x plus 17 equals 0. X is equal to 4. If you use your calculator, you may get some decimal, but you're still not strong enough to prove that it's irrational or rational. So you must express in short form. X is equal to negative something, positive negative b squared minus 4ac divided by 2a. You must memorize it. And then b is negative 10, a is 1, c is 17. Positive negative square root 32 over 2. This one is strong enough to prove it's irrational, or you may simplify it, but it's totally not necessary. So 2 square root 2 here. And then therefore these two roots are irrational, and then this root is rational. So your conclusion is only one rational root in this situation.